Hello everyone. In this video I'm going to take a close look at a data structure in Python called a list. For the code portion of this video I'll be using PyCharm Community Edition. First of all though, in case you're not familiar with the term data structure, it is a collection of data values, the relationships between them, and the operations that we can perform on that collection of data values. Now there are many different types of data structures in programming, and various programming languages support some or all of them. So in this video, we're going to take a close look at the list data structure. Now lists in Python have several attributes. For example, they're heterogeneous, meaning they can store different data type values at the same time in the same list. Lists are ordered, so as I place items in the list, they remain in that order unless we use a method to change or alter that order. Lists are mutable, which means I can change the values in my list. I can add values and remove values, etc. Lists allow duplicates, so I can have multiple values in my list with the same numeric or string value or whatever the data type might be. They're also indexed, which means each list item has its own index value that I can access individually. Lists are also objects, so in Python we have what's called methods, and we can use methods to manage our lists, and we'll take a look at that in a minute. And also lists can be nested, meaning I can have a list inside of a list, and we'll look at that as well. One thing that can help you understand how lists function is how they are stored in memory. If you're familiar with how a variable in Python is established and how it's stored, this image here shows that we create a variable called age and we assign a value to it. In the memory of the computer, that value of 25 is stored in a memory address. But we don't have to know what that memory address is as long as we have access to that variable age. So in this example, age is the label or the name that we've applied to that memory address, and all I have to do is say age, and I can access the value that is stored there. In lists, we have a similar concept. We have a variable name, in this example, my list. But the difference is, while that variable points to a memory address, just like with a variable with a single value, it actually stores the block of data values that we have in our list. And you notice here that it has indexes for each value that is in my list. In this particular example, I have 3 items in my list: apple, orange, and pear. So I can use my list, a single value variable, and access any individual items in my list using the index. This is similar to the way we can index and access individual characters in a string. So the first thing we'll take a look at in PyCharm is how to create lists. The general form of creating a list and assigning values to it is a variable, the assignment operator, the equal sign, and then a set of values inside of square bracket. I can also create a list that is empty, like in this case. For example, if I were to print this, I created a list called my list. It is assigned nothing. There's nothing inside the square brackets. If I run this, I see that it does have the list in memory. There's a location for my list, that variable, but at the moment, there's nothing in it. Next, I'll create a list that actually has values in it. And if I print this list, PyCharm will show us the list in the form in which we created it. As I said earlier, lists are ordered. So notice that I created this with the data values 2, 4, 6, and 8 in that order. And so that's the way that they're stored in memory and attached to my variable int list. And so that was a list of integers. That is a list of strings. Now, because Python is a dynamically typed language, There's no actual connection between the fact that I have two lists, one that has integers in it and one that has strings in it, to the variable names, other than the assignment. In fact, because as I said earlier, lists in Python are heterogeneous, meaning I can place different data types in the same list. For example, maybe I have a list that's going to store a record for an employee. Notice that we have several data types in this same list. I'm kind of imagining here, this is maybe the employee number, first name, last name, the department they work in, their age, maybe their hourly pay rate, and a Boolean on the end, maybe that indicates whether they are subscribed to the company health insurance or something like that. Notice that the data types in this list are heterogeneous. So I have multiples. So the only thing that I'm concerned about is the variable name. As long as I know that variable name, I can access any element, and it doesn't really matter what data type that is. I also mentioned earlier that lists can be nested. So we know that the syntax of a list is the variable name equals a set of square brackets. And any position inside that list is indexed, right? So, for example, in our previous ones, this value that I said, maybe it's the employee ID, is in position 0. Indexing, like with strings, in lists starts with 0. So this would be position 0 in the employee list. If I want to nest a list inside of a list, I put another set of square brackets. Now I have a list called nested list equals, and a set of square brackets. Inside that set of square brackets, I have another set of square brackets, which actually is a list inside of a list. So nested list, the index 0 is a list. We'll actually look at how to access that in a second. Let me show you. We'll just create I'm just kind of creating some values here to get the idea. So a couple things to notice here. One is it's heterogeneous, right? I have strings, and I have integers, and I have Boolean values and float value. And I have two lists inside of my nested list. That's what's meant as these are nested. Also notice in this list that I have some lists, but I also have some individual values. In a minute, I'll show you what this kind of looks like in memory as well. So there's our set of lists, and let's take a look at the indexing. If I were to print my int list, and in a set of square brackets, I put a 0, and I run this, I get the number 2, which is this 2 in my int list in position 0. That's the index value of that particular data item. If I put an index of 3 and run it, I get 8, which is at the end. Keep in mind this is position 0, 1, 2, 3. And if I put 4, I get an error. List index out of range, because this list only contains 4 elements, but we start at 0, 1, 2, 3. There is no position 4 in terms of the indexing. Same thing with my day of week list. Same idea. I can put index values there, run this. I get Thursday. That's because this is position 0, 1, 2, 3. It works the same all the way through, and as I said earlier, because lists are heterogeneous, I can have different data values. So in my employee list, Python handles the fact that as long as I give it a valid index, I will get the value back. Now it's up to me to determine or to be aware of or be able to work out what data type that is. There's no indication of that from Python directly. So if I need to know, if I'm not familiar with it, then I would have to work that out myself. But I have that value regardless of what the index is without having to do any type of casting directly. If I print the entire list, again, like we saw earlier, I get all of the values. So up to that point, the way this looks in memory is, if you remember, we had an empty list called myList. There's no data values in that list, so there are no indexes yet. As I add items to that list, then of course it would begin to build a list for me. And I could access those items using the indexing. The int list, we used a couple of indexes to take a look at those values. Just like with strings, I can use indexes from 0 through the length of the list -1, or I can start at the end of the list and work backward using a negative indexing number. So in these examples I have here, the int list has 4 elements starting at position 0 through 3. My day of week list has Monday through Friday, which is 5 elements, and again, positions 0 through 4. My employee had 7 elements total, again 0 through 6, and I can work backwards or forward as usual. Now the nested list is structured the same way. Notice that I have my nested list, I have indexes 0, 1, 2, and 3. If you remember from PyCharm, we had a list, and then we had the value 99, another list, and the value of 44.599. The value at position 1, the 99, is an individual value. It's just like the lists above. And position 3 is storing a float. It's the same concept. The change comes with the fact that we have a nested list. So if I want to access the nested list, I actually will use 2 indexes. The first, the primary list, and then a second index to indicate which element of the nested list that I want to acquire. Let's take a look at that in the code. So the first thing I'll do here is I'll say nested list, and I'm just going to say position 0. Think about what I'm asking for here. Even pause the video maybe and try it out, or be able to answer that question. What is going to print here? What prints is the nested list, my apple, cherry, pear. Because this entire list is at position 0 of my primary list here, that's what I receive. If I wanted just the word cherry, I want to drill into the nested list, the way in which I would do that is access it based on the index of the nested list, meaning apple is at position 0 of the nested list, cherry is at position 1, and pear is at position 3. Imagine this as a list by itself for a second. The syntax to get to that is just a second set of brackets and then whatever position that I'm after. If I run this now, I get the word cherry. Okay. You notice that the first index says, hey, the list that I'm after is in position 0, and the individual element of that nested list that I want is position 1. So if I want, let's say I want the last value of the second nested list, well, that's at position 2. This is position 0. This is position 1. This is position 2 of my primary list there, so I change this to 2. And then inside that nested list, it's position 0, 1, 2. And I get true, which is this value right here. A very common task with lists is to iterate or loop through the entire list and do something with each value. So we'll use our day of week list that we saw earlier. And we'll use a for loop. We'll just very simply print each element in this list. We have the for statement. We have a variable that we'll use inside of our loop to work with our list. We use an operator called in. We've seen that before. We talked about loops in a previous video. And our list variable name. And all we're going to do is print each element. So as this iterates through the list, it'll start at position 0. I don't have to instruct Python to do that. This is by default. If I use this particular for loop signature, the structure of it, and the in operator, it will start at the beginning and it will loop through to the end of the list, regardless of how many elements are there. In this case, we have 5. This would work if I had 5 elements or 500 elements or 500,000 or 500 million. If I run this, notice that I get my list. Each element is on its own line, and the reason is because for each iteration, it uses print with no parameters. So the default behavior of print, of course, is to print whatever's inside of it on a line and move to the next. So it's a very simple example of iterating or looping through a list. Another common task with lists is to iterate through the list and perform some operation on every element in the list. In this next example, what I want to know is, what is the sum of all of the integers in this list? So I want to iterate through the list and create a running total from the beginning of the list through to the end so that I know what is the total amount that's in this list. So I'm using the same syntax for the for loop that we used in the previous example. So let's take a look at that. My for loop is saying loop through this list, and as we said in the previous example, Python will begin at position 0, the beginning of the list, and work its way all the way through to the end of the list. So it handles that iteration for me. And then on line 4, I'm creating a simple running total. So in my tote variable, I'm going to have every element of the list that will be in the variable I added to the running total. And then it will print after the loop is finished. And I get the value 20. So if I were to add some more values to this, it doesn't matter how many values I have. Because of the way in which the for loop functions and the in operator, by default, it's going to take the entire list and iterate through each element. And just to round out some examples here, we'll use a while loop as well. I went back to our day of the week list. I'll give myself a counter here. And I'm also going to introduce using the len function, the length function on lists. And incorporate indexing here as well. So let's take a look at that code. We have a list of the days of the week, a set of strings. I create a counter variable on line 2. The while loop is going to iterate through this list using that counter variable. Now, we saw in the for loops that that is automatic for us. This is just demonstrating another approach. And particularly just to show that the len function length is a built-in Python function that we can use with lists that's going to give us the number of elements in the list. Again, it won't matter how many elements are there, we'll always get that number. So we can use that to our advantage in a case like this if we want to use a while loop, for example, and this particular approach to structuring our iteration. We also have indexing here. I'm using that I variable, so each time it iterates, starting at 0, since that's what I said at the top here, it will begin with the very first element and work its way through. And I increment that each iteration through the loop so that by the time I get to the len, the length of this, in this particular case 5, then it will finish and exit the loop. Run this. You notice this is the same output that we had in the first example using a for loop. You might wonder, well, which is the best approach? The approach is really dependent on the problem or the domain that you're working in. There's not necessarily this one's right and that one's wrong. It's largely dependent on what you're trying to accomplish. So iteration is a very, very common thing that we do with lists. Something really worthwhile to practice and become familiar with, combining list iteration with either type of looping structure and also incorporating some indexing in there, all as practice. So as I mentioned at the beginning of this video, lists are mutable, which means I can change the values of the elements that exist in a list. So I'm going to create a new list here. Okay, with some values in it. Just print that. We know what that looks like. Get the values 1 through 9 and the 0. So let's say I want this list to be the numbers 1 through 10. And it's been entered already in this form where the 10 looks like 0. And I say, well, that's not how I want it. So what I can do is address that particular index in the list and simply change its value. If you think about this in terms of simple variables, if I declare a variable to a value, later on I can just use this same syntax of putting the variable name, the assignment operator, the equal sign, and a new value, and it replaces what value was there before. This is the same concept. The difference is I'm using an index value because numList is a list, right? And this is position 9 because there's 10 elements and we start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's run this. We'll print the list a second time. And we see now, originally we had 0 in that 9th position. Now we have 10. We also have the ability to do this using slicing. We're combining our earlier concepts. Let's say 4 to 6. So think about that for a second. You pause the video and try to determine, without putting this code in, what will this do? So similar to what we did on line 3, we're changing the value of an individual indexed item in our list. In the case of line 5, because I have slicing available to me in Python, this is a shorthand version of saying, hey, I want numList position 4 to equal 99. And I also want numList position 5 to equal 98. And I want numList position 6 to equal 97. I could do that in 3 lines of code, or I could use the slicing syntax and do it this way as well. Notice that positions 4 through 6 have now been changed to this set of values. As long as I provide it the same number of values as my slice, then it will use those values in order. So this will be the first position of my slice, the second position, the third position, etc. As I said early in this video, the list data structure is very widely used in Python development. You can start to see the reason why. If I need to store data in memory and work with it, this is a great way to do that because I have basically this structure that I can place pretty much any value inside of and then work with it, update it, change it, add items, remove items, and we'll look at that in a minute. And its flexibility makes it very versatile. The next feature of lists we want to look at is the ability to add items to the list. And we have a couple of ways that we can do this. There's a couple of methods available to us for the list data structure that allow us to either add an item to the end of the list. That's called appending. We can also use what's called extend, which allows us to add several items to the end of the list. And then we also have insert, which allows us to place an item in the list anywhere, as long as we know the position that we want it to be inserted into. So we'll print this list as we have been, so we see what it looks like to start with. So the numbers 1 through 5. If I use the append method, then I can place a value here. And let's take a look at the list again. And what this will do is we'll append whatever value I place here to the end of the list. So I see that I have my original 1, 2, 3, 4, 5, and now I have a new element on the end, the 111. I can use the extend method. Keep in mind that methods always have a set of parentheses after them. And whatever we need to provide to that method, parameters they're called, goes inside those parentheses. Well, in this case, we need to provide a list to the extend method that will add on to the end of our list. Well, this is similar to that nested list concept. I need to place that list of values inside the square brackets, which need to be inside the parentheses for the method call. Okay. So if you look at this syntax, what I'm telling it is take this list and add it or extend it onto our original list. Okay. So that's why we have a set of parentheses and a set of square brackets. Okay. And we'll run this. So now we have, there's a couple things to notice here. Our original list, right, 1 through 5, we used append, which added the 111 to the end. And notice that our third change to this list is including that 111, and the reason is because that list is continuously being updated or changed or modified, and appending values or extending the list is actually adding to the original. And then of course we have the 3 values that we extended using this list. So this is actually a way in which we can merge 2 lists together in a sense. We're taking a list and we're just adding another list to the end of it. Keep in mind also, if you remember from the earlier in this video, the list data structure allows duplicates. So if one of these values happened to be the same as another value that was already in the list, I would end up with 2 elements in the list of the same value, which is perfectly fine in Python. The next method to take a look at is insert. The insert method allows us to add something to the list, but in this particular case, it won't add it to the end necessarily. It adds it where we tell it to add it. So if I were to put 0 and a value, the first value inside the parentheses for the insert method says, what position do you want this value to be inserted into? So in this case, I've said 0, which should be at the beginning of the list, and this is the value I want inserted, 777. Print my list again. Now notice that the list that we have built so far gets shifted 1 position, and that value that I indicated I wanted inserted is inserted at the position that I specified. And this can be anywhere in the list as long as it's a valid index value. Let's say position 6, some number. And run it. In this case, our list as it stood before line 9 of the code is in this form. The first portion of the list stayed the same. I had said position 6, so at position 6 it inserted that large number and shifted everything else over to the right. So this is important to understand, that the insert is actually modifying not only the fact that we have new values in the list, but it's placing those in different positions which means the order of our list is actually changing. So that's important to be aware of, because if that's a problem for your application, then you'll have to take that into account. Another way that we could add items to the list, and this is not using a method, is similar to what we can do with variables. We can use the plus operator and use this syntax to say, take my list and add another list to the end of it. This is very similar to using the extend method. It's just a different approach. So now we have that list, this list of 5s, added to the end of our original list. So this demonstrates multiple ways of extending or adding on, inserting into values into your list. This also combines the concept of our indexing, right? So in this case of the insert, for example, I can place values anywhere in the list that I have access to. So the next thing with lists, because they're mutable, we've seen how we can add or insert items in a list. We can also remove items from the list. So let's start with a list of strings. And as usual, we'll print that, see what it looks like. To remove an individual element from our list, we use a built-in function in Python. This is not a method of the lists. And we give it an index value. So this statement says delete from the list whatever is at position 2. So position 0, 1, 2. So I'm deleting the CC element from this list. Notice that CC is no longer there. Also notice that the list has been shifted. The shifting of the elements in the list is happening behind the scenes for us. We don't have to handle that ourselves. That is part of the data structure, the ability for the operation to handle repositioning elements as we add or insert or delete items from it. We can also use our slicing syntax as we have seen before. In this case, it's going to delete from positions 3 to 5. Okay. You notice a pattern here as we work through these different operations with the list data structure. We have the ability to use slicing. We have the ability to use the indexing as we need to. Okay. And again, this removed the last couple of items, which were in positions 3 through 5, and I'm left with the few items shown here. Another thing that we can use delete for is to literally delete the entire list. If you're working on a large-scale application or you're working with some sort of device that has limited resources, memory resources, oftentimes it's really important to remove variables and data structures that you're no longer using. And so one way to do that in this is to say, okay, I'm done with this list. It's consuming memory, right? Now, obviously, it's not consuming a lot of memory with 3 elements in it, but what if this had 3 million elements or 300 million elements, and it was just sitting out in memory and I'm not actually using it anymore? I would want to delete that to free up those memory resources. Now I'm going to use the print statement here like we have been, but that's going to give us an error, right? Because this line, line 7, is actually going to delete that list. So when I run this, I get the error that says, hey, that's not defined. That means it's no longer in memory. I've removed this variable from memory, which means it's no longer accessible. It's no longer there. So the next thing to take a look at is that there are additional methods of the list data structure that we have available to us as well. If we start out with a couple of lists here, one of the methods we have available is called copy. Let's say I want to do this. So the copy method of this list 1 that we created up here. There's no need for parameters here. It will take whatever's in list 1 and build a new list based on my new variable name and make a copy of list 1 in its entirety. So let's run this. So on line 3, we use the copy method to copy list 1 into new list. If I print both of those, obviously, from the output, we see they're identical. So now I have 2 variables pointing to 2 separate lists, and I can now manage those lists individually if I want to. Another method that we have available to us is called reverse. The reverse method will take all of the elements in a list and reverse their order. And also notice that this is a statement by itself. This is not printing directly, which means that reverse is what's called in place, meaning now the variable new list, the data elements for it, are physically changed their order. So this is the list that we originally copied, and now we have reversed the new list. And then the last of these, let's go back up here and get rid of that. Notice that list 2 has a duplicate value in it. A common task is to sort a list. So if I wanted list 2 to be in numerical order, I can use sort. That's another method. Actually, let me print it first so you can see both. There's the original copy of list 2. After the sort method, there is the sorted version of list 2. There is a reference sheet of all of the list methods here at this URL. So earlier, I mentioned that we can use the built-in Python function len for length to determine the length of a list. So in this case, there are 5 elements in this list. Length is a built-in function in Python, and there are other functions that we can use with lists as well. For example, I can use the maximum function that tells us what the largest value is in this list. In this case, it's 5. There's also minimum. I run this. Shows the smallest value, in this case because they're integers. The smallest value is 1. We saw the in operator when we were using for loops. We can use that operator with lists as well. Let's say I want to know if the number 2 is in this list. Okay. So if we read that kind of in English, we say, is 2 in this list, that value? And it says true, which means yes, it is. If I do the same thing, but I put a value that's clearly not in this list, I get false. Okay. So we can combine many of the concepts that we have learned so far in Python, that because the list data structure is an object, we have methods, right? We also have the built-in Python functions that are available to us that we can use on any what's called iterable, which is a structure like a list, and we'll see some others as well going forward. We also have the ability to use operators like the in function here. A couple of others, for example, let's make a copy of this list. Just here in the editor, I mean. And we'll just change a couple of these values. Just make these all 10s. Why not? So now I have 2 lists, right? I have list 1 and list 2. Another operator that I can use that's straight out of what we have already learned is the plus. Okay, we use this in strings, right, for concatenation. You can do the same thing with lists. This says take list 1 and list 2 and just add them together. Okay, so now I have, that's list 1 and list 2 as one combined list. We can also use, same syntax here, the equality operator to ask the question, hey, are these two lists the same? Do they have the same elements in them? And it says false, of course, because this is 1 through 5 and that's 10 through 50. Right? So this ability to combine operators and built-in functions and methods and indexing and slicing, all of these things are things that would be in your best interest to practice as much as possible. You know, you can find examples online, or you can just make up examples. It's pretty much what I've been doing here, of different types of lists and different types of data structures as you learn more, and apply all of these concepts to manipulating and managing and modifying data structures like lists. As mentioned earlier, lists have a set of attributes. We've covered those, shown how to add elements and insert elements and modify the elements, remove elements, use the various features of Python with lists. All of these factors is why lists are so widely used and very, very versatile within the language. If you have any questions, don't hesitate to let me know. And thanks for listening.